Hey, this is Mr. Lum, and here's your answer key. So you should have done this first before you see the answer key. And hopefully the substitute teacher the TOC is playing this towards the end of the class. Anyways, so we're going to talk about some of the answers here, and hopefully you're on the right track. And I'm going to go a little bit faster than what I did in the explanations earlier. For this first one right here, we have a single element plus a compound. That's going to be a single replacement. The calcium is going to come in and make calcium nitrate. Calcium is 2+, so it's going to have 2 right there, and zinc is going to be by itself. Zinc is not diatomic, so there is no numbers after there. This next one is going to be a combustion, and all combustions make CO2 and water. Okay, I haven't balanced these things, but we can balance them. So I have 2 carbons on one side, so I'm going to put 2 on this side, and I have 6 hydrogens, and so I'm going to put a 3 right there. Okay, now I have to balance the oxygens, and so I have 4 plus 3, and so that's 7, and so that's going to be 3.5. Okay, it's completely fine to have a decimal or a fraction when you're balancing, but if you didn't want to have any of that, then just double everything: 2, 7, 4, and 6. Here we have a double replacement, and how I know that is because we have a compound plus another compound. They are not acids and they are not bases, so it's just going to be a double replacement. We're going to switch out the 2 metals. So instead of sodium being with sulfate, sodium is going to go with nitrate. It's going to be NaNO3, and Na is +1 and NO3 is -1, so there's going to be no prefixes associated with it. Or sorry, no subscripts after it. Ca, calcium is 2+, and sulfate is 2-, so it's just going to be CaSO4. Okay. We have to balance this, and so I'll put like 2 right there. Now, this one's a little bit kind of weird. We have this very large compound right here, and in the previous video, I had you do something that wasn't perfectly correct, and it was mainly because of this question right here. So this one compound is just going to break into all of its components. It's going to break into mercury. It's going to break into hydrogen. Now hydrogen is diatomic, so it'll have the 2 right there. And then it's going to break into phosphorus, and then it's going to break into oxygen gas, so O2. Okay, this is going to be a decomposition. Now, in terms of balancing right here, it becomes pretty simple to balance because everything is kind of by itself. So there's 1 mercury, 1 mercury. You can place a half right here if you want. Okay, so now that's 1 hydrogen on this side and 1 hydrogen on this side. Half times 2 is 1. And then a phosphorus, and then we need to place a 2 right here. Okay, now if you don't like that half, you can times everything by 2. So you'd have to place a 2 right there, 2 mercury, just be 1 hydrogen then, and then 2 phosphorus, and then 4 oxygens. Okay. We have a lone element plus a compound. This one is a non-metal, so it will replace the non-metal in Ki. So it will turn into KCl. Okay. Potassium is 1+, and chlorine is 1-. When they swap and drop, it's just KCl. And so this is going to be a synthesis reaction. Now, the iodine is going to get kicked out right here, and since iodine is part of the diatomic 7, it is going to become I2. And for balancing, I'm going to place a 2 right there so that I could have 2 chlorines on both sides. That kind of throws the K off a little bit, so I'm going to put a 2 right there. And I look at the iodine and it's all balanced. Okay, so hopefully you had something like that. I forgot to mention on the previous recording, I had one of the questions there said something like Hg, HPO4, and we said that it broke down into its components of He plus H2 plus P plus O2. On the previous video, I gave a similar example where I said calcium hydroxide plus heat, and I told you that the answer makes calcium plus oxygen gas plus hydrogen gas. I do want to kind of like that is a little bit of a lie. I mainly told you in the first video at the start of class that this is true so that you would get this answer right here. But in reality, this reaction doesn't actually occur. What actually happens for calcium hydroxide when you add heat to it, it'll turn into calcium oxide plus water. So this is the real reaction right here, but in the very first video at the beginning of class, I told you this one right here, just so that you would get this one right. But I just wanted to kind of like say I made a little bit of a lie on that one. So anyways, moving on with our answer key. We'll go over some of these ones really quickly and see how I did it. So I am going to go move a little bit faster. So again, this one right here is going to be a single replacement because we have a single element plus a compound. The metal is going to replace the other metal, which zinc is going to be replacing lead. So it's going to be zinc and ClO bracket 2. Zinc is 2 plus, and so therefore it replaces ClO2 just like that. Chlorite or ClO2 is 1 minus, and so when you swap and drop, it's just Zn bracket ClO bracket 2. And then Pb is going to be left by itself. Pb doesn't have any subscripts on it because it's not diatomic. It's not part of the diatomic 7. Moving on, we have a compound right here plus another compound. So that's going to be double replacement reaction. They're not acids and they're not bases, and so that's why it's double replacement. So this one right here for cobalt, the charge on cobalt is going to be 3 plus. I know that because iodine has a 3 next to it. So we're going to write here cobalt is going to be CO and then CrO4. Now chromate, CrO4, is 2 minus, and cobalt, we just said, is 3 plus. So when we swap and drop, it's going to be CO2 bracket CrO4 bracket 3. Now plus ammonium, NH4. Ammonium is 1 plus, and iodine is 1 minus, so it's going to be NH4 I. Okay, swap and drop NH4 plus, I minus. There's going to be no subscripts on that one. Okay. Now we have the other annoying task of making sure that these things are balanced. Now I'm going to show you the improper way of balancing this one right here, just so that we can to show you what it looks like and what you do if you do start to balance it improperly. So I'm going to balance this one improperly by saying NH4 is, there's 2 right here, and so I'm going to place a 2 right here. Okay, now if I look at iodine, iodine has now 2, and this iodine has 3, and so I get into this scenario where that can't really be balanced. So if you get into a scenario where you're like, that doesn't work, erase it and try again, but in a different spot. So I erase these things, and now I'm just going to try again in a different spot. And the place that I'm going to try is I'm going to balance my cobalts. So I'm just going to grab my pen, and so I'm going to go, cobalt has a 2 right there, so I'm going to place a 2 right there. Now, the iodine has switched. It's now 2 times 3, so there's 6 iodine. So I'm going to be placing a 6 right there. Now, the NH4 now has 6, and this NH4 right here is 2, so I'm going to place a 3 in front, and that gives me 3 chromates, and I already have 3 chromates, so now it is all balanced. Okay, moving on to this one, I have a hydrocarbon and an oxygen, so I know that one is going to be combustion reaction. And all combustion reactions, unless it contains sulfur or nitrogen, is just going to make CO2 and water. Now, we're going to balance this thing, and I'm going to go 10 carbons right here, so I'm going to place 10 carbons on this side right here. Now that's balanced. Now this one's a little bit tricky to see how many hydrogens. We have 21 hydrogens right here, plus 1 hydrogen is 22 hydrogens, and so I'm going to need 11 hydrogens on this side. So 11 times 2 is also 22. So now my hydrogens are balanced. So carbons are balanced and hydrogens are balanced. So now I have to balance the oxygens. So on this side right here, I have, at this point right here, I have 10 times 2, so that's going to be 20 oxygens plus 11 oxygens. So I'm going to have 31 oxygens on the product side. So I need to have 31 oxygens on the reactant side. So here I got 1 oxygen right there. So if I can make this number look like 30, then it'll be balanced. And thankfully I can just go like this. 15 times 2 is 30, plus the 1 is 31 oxygens. Okay? And so that's balanced now. Okay. So now I have barium hydroxide plus nitric acid. This is a base. This is an acid. So that means it's going to make water and salt. Now it's not going to be the conventional salt that we put on food, but it is going to be barium nitrate, BaNO3. Now, NO3 is -1, barium is 2+. When I swap and drop, Ba bracket NO3 bracket 2. Okay. Now, you can balance this kind of the conventional way, like you balance all reactions, or you can use my method and realize that this base is like a 2 base, and this acid is a 1 acid. I know this acid is a 1 acid because it only contains 1 H, and so we call it a 1 acid, or the fancy way of calling it a 1 acid is a mono, meaning 1 protic acid. It's a 1 acid and a 2 base. So the easiest way to balance it is make sure that they are the same. So if this is 2 bases, I make this 2 acids. 2 bases plus 2 acids make 2 water, and it's balanced. Since it's an acid-base reaction, it's a neutralization reaction. Okay. Moving on, it has a little note right here. Assume that copper is 2+. I didn't mention this before, but like if I don't tell you, like, assume it, then what you should be doing is looking at the first ion charge. If it's like a multivalent element, you should be just choosing like the very first ion charge that you see on the periodic table, the top one. And so if you looked at like copper on the periodic table, copper looks like this. It has 2 ion charges. It has 2+ up here and a 1+ right there. The reason why they write this one in the top top right-hand corner is because it's the most common one. So just always choose the first one if it doesn't tell you what it is or you're unable to figure out. So for this one right here, we were able to figure out what is the charge on cobalt, and it happens to be 3+. And I think that 3+ is not the most common ion, but you have to use the 3+ ion for cobalt for that one. Anyways, getting back to K, it says Cu is 2+, it gave us that, and if it didn't give us that, we would just assume that because that is the first one on the periodic table. And so it's going to be Cu O, Cu 2+, O 2-, has a total charge of 0, so we just need 1 copper and 1 oxygen. Okay. Balancing, we have 2 oxygens here, so we're going to place a 2 right there. Now we have 2 oxygens. We messed up the copper though, and so we're going to place a 2 right there. So now it's all balanced. These are 2 single elements coming together, so this is called a synthesis. Okay. Now, for this one, I kind of mentioned at the beginning, we have one very, very large thing. So we're just going to say that breaks up into some smaller stuff. So we're going to say that it breaks up into lithium, arsenic, and oxygen. Okay. And oxygen is diatomic, so don't forget to write the 2 right there. And then we're going to say that this is decomposition. Okay. I did tell you you can write this in like just breaking it up like that. I do want to emphasize that not everything just breaks up into its elemental form. There are a lot of like decomposition reactions that often break into a compound plus an element or something along those lines, but we'll just kind of say that it breaks up into these different kind of like elements. Okay. For balancing purposes, there's 3 lithium on that side, so we're going to put 3 lithium on this side, and then we're going to put a 2 right there to make sure that the oxygens are balanced. Okay. Hopefully that makes sense. If you have questions, I'll be in tomorrow.